Good evening. My name is Matt Oswalt, and I'm here to talk to you about QoS on a Nexus 5000 series switch. I actually got two 5548 UP switches to play with for a few hours, and QoS was one item I just had to cover. So let's get started. This is going to be a real simple topology. Obviously, I mentioned I only had two switches, so I basically formed a port channel between the two originally, but then I kind of reconfigured them separately. So right now, the test that we're going to run is going to be only over Ethernet 1.1. Getting into the command line of the first switch, we'll just do a real quick show run. I've configured a few things, but nothing related to QoS. I set up an SVI, which we'll see in a little bit. The first thing I want to do is I want to show you the basic QoS configuration that comes with the switch. There's quite a few class maps of various types, but the main thing that I want you to look at below these class maps is the QoS policies that are applied. We're going to get into exactly what that configuration does later, but I want you to see what the default is. Going down, as I mentioned, right now both of the interfaces are configured to be in a channel group. Right now Ethernet 1.2 is unplugged, but they're both in port channel 10. We also have an SVI configured on this switch for 10.1.1.1 that goes over that link, and then the other switch is configured as 10.1.1.2. Just to verify that we can ping the other switch, we can. Good. So just regular pings are working. We'll be doing a little bit more ping testing later, but I want to show you a new command that I recently learned that is really good for QoS. You can't run it on port channel interfaces. You can only run it on physical Ethernet or fiber channel interfaces, so we'll just do it on Ethernet 1.1 since we know that's what we're using. And what this does is it shows you the queues that are on that interface. By default, we have QoS groups 0 and 1. 0 is for Ethernet traffic. You'll notice that they all have basically an operational bandwidth of half, and we'll go into what exactly the bandwidth, what this configuration does later. But right now, we've basically got two QoS groups. One of them is QoS 0, which has an MTU of 1500, and what that's going to be is basically all traffic. That's your default QoS group. There's a queue size attributed with that. As I mentioned, the MTU is 1500, which is the default for Ethernet, and this is just because of the way that the policies are written right now by default. We also have QoS Group 1. You'll notice that it has an MTU of 2158. This is actually the queue that FCoE traffic falls into by default. So Nexus switches are configured to support FCoE correctly with the correct MTU that FCoE requires, which of course is the larger FCoE size. So just to look at the QoS configuration again for reference, what we'll be doing is creating our own QoS configuration that allows us to properly classify traffic. As you can see here, it's got a few class maps in there. It's not really doing much to classify anything except for the default classification, which is really just identifying that traffic is FCoE traffic if it is, and then everything else kind of just falls into the default. So we're going to configure a class map of type QoS, and we'll go into that here in a second, but I want to create a platinum class map, which is basically the good traffic. You'll see that we can match on quite a few values. We can take a look at that here in a little bit, but I think right now the only thing that I want to do right now is just match on cause value, which is just a layer 2 form of basic quality of service markings. You can also notice that we can do NBAR, basic NBAR, by matching the protocol. We can also match on RTP. We can match DSCP values. This match statement is really where we get granular with some of this behavior. But like I said, our preference here is to match on a cause value of 5 for platinum. What we'll do is we'll vary the cause value based on the class that we are using. Again, we'll keep going down the class maps. We'll define one called Class Gold, and again, this is just a way of tiering our traffic. We want to have certain priorities to certain types of traffic and do certain things with those types. So we've gone through Class Gold. You'll notice that I just ran a Class FCoE command. You'll notice that it was there before we did anything, so it is a default class. And there are certain rules about default class that we will be running into in this entire video. One of which is the class FCoE has to be configured as match any. And the difference between the two is if you have multiple match statements, if it's match all, then all of them have to match, and if it's match any, then any one of them can match. If the condition is met, then the traffic falls into that class. So basically, we only have one match statement, but let's say we had another match statement. Say we're also matching DSCP values. If it matched one of them, then it would fall into that class. And I just wanted to go through class FCoE here again. We're matching on cause value 3, but it should be noted that the cause value of 3 is the default cause value for FCoE traffic. So we can even delete the cause value of 3 and still show that class map, and it'll still say match cause value of 3. So that's the default value for that class. Class map type QoS match all class gold. I believe we've already done this, but let's just write it anyway. Our cause value 3. Or I'm sorry, we don't want to do cause value 3. It was what was it? Show class map type QoS match all class gold. That's not right. Yeah, there we go. Okay, cool. Cause value of 4. Yep. There we go. So class map type QoS match all class silver, and this is going to be class map type QoS match. We want to do the cause value first. Sorry about that. I lost where I was. There we go. Match cause 2, class map type QoS match all class, and then bronze is the last one. And match cause 1. So we have all of our class maps, and I'm just going to show you the class maps in summary so we can see that they're all configured. They're out of order according to what we configured them as, but they do have the cause values that we wanted. So platinum is 5, gold is 4, FCoE is 3, silver is 2, bronze is 1. And those are the ones that we manually put in. You'll notice that the default FCoE class is up there. That's a class that's going to be there no matter what. And then there's another one, class default, which just matches any type of traffic. And then we've actually got two others, class all flood and class IP multicast. And these just capture all flooded traffic, and then the last one captures all multicast traffic. You'll also notice that for all of the default classes, other than class FCoE, we can't even get into the context for them because they are default classes for type QoS. So we can't even get into them. That it gives us an error, so we can't change them in any way. So whenever you have QoS configuration, class maps are responsible for identifying traffic, but they are useless without a policy map. So we look at the type of these class maps, which is type QoS. If you look at the policy map that we're creating, we're using the same type. What that means is the class maps that we refer to in this policy map will need to be of the same type. So now we can refer to those class maps that we just created by running the class and then class-platinum, which is the name of the class that we created, and it takes us into a context for that class. And now we can do things for traffic that fell into that class. For instance, we can set the DSCP or precedence, but the one thing that I want to do here is inject these packets into internal QoS group mechanisms. And this is not something that is transmitted on the wire. This is a way that the switch keeps track of where the traffic is logically inside memory. QoS group is more or less just a queue in and of itself. It's not on an interface. It's just in RAM. It's a way of keeping track of traffic. So we'll set QoS group 5 for platinum traffic. Gold will get QoS group 4. Silver will get let's do QoS group 3. And there's a reason I'm using that. We're going to get to FCoE here in a second. Bronze is 2. And then finally, the last one we're going to do is actually class FCoE. And we're going to set this to a QoS group of 1. And again, class FCoE is not a class that we created. It is a default class within the switch, and we're setting the QoS group to 1. You'll notice that just like a cause value of 3 is the default for FCoE, QoS group of 1 is the default for FCoE as well. So now we can show policy map, and we see that the policy map of FCoE default in policy is there, and these are all type QoS policy maps. But the default that comes with the switch is FCoE default in policy. There's also one that's just regular default in policy, and then finally there's the one that we created, which has all of the set statements for each of the classes that we created. So the class maps of type QoS classify the traffic, and then this policy map uses those classes, or class maps rather, to do stuff with that traffic after it's been classified, namely further classifying it into QoS groups, and we'll see how those link together here shortly. I do want to take a second and show you the different types of class maps that we've created. I mentioned that we created QoS type class maps. There are a few class map types, and actually each class map type has a corresponding policy map. There's network QoS, QoS, and queuing. We will not be using the control plane type QoS or policy map or class map in this video. So we created the QoS classes and policy map. Let's try creating a queuing class maps. And these class maps, what they do is they match based on the QoS group that we just set. So we've classified traffic into QoS groups based on the QoS type class maps and policy maps. Now with the queuing type, we're actually matching on that. So for instance, platinum gets 5, gold gets 4, silver gets 3. And now we're matching based on those statements with completely new class maps of type queuing. So these do not have anything to do with the class maps we created before because they are type queuing, whereas the class maps we created before are type QoS. So here we're actually matching based on QoS group. So it's important when you make these configurations that you understand which goes to which, because it can get confusing. Where cause value gets matched up to QoS group value. You got to make sure you understand the defaults for various default classes, but then also the ones that you create, make it make sense to you. So yeah, we've got all of these QoS class maps, and remember, these are type QoS. Those are the first ones we made. And then obviously we created a corresponding policy map. That's the same type. If you go down here, remember we're creating class maps of type queuing. So these are not going to conflict with that. But just like before, the class maps are useless unless there's a policy map that uses them. So we're going to create a policy map of type queuing, just like these class maps are. We're going to call it uplink out policy. And the first thing we need is to define class type queuing class platinum. This is referring to the class map that we just created. The cool thing about policy maps of type queuing is we can actually do stuff with traffic at this point, because it is the policy map that affects traffic that is leaving the switch, thus the name uplink out policy. So here in the platinum traffic type, we can say bandwidth %10, and again, this is just a bandwidth guarantee. Obviously, it's not a limitation. So if the switch is not experiencing congestion, then more than 10% is fine. QoS really only has a big impact in most cases when the switch is undergoing congestion. So this is just a bandwidth guarantee for this class. And obviously, you can change this for whatever value you want based on what traffic you know will be in there. So class type queuing, class gold, let's give it 20. Class silver, let's give that, let's do 20 as well. Yeah, that's fine. And then class bronze, there we go. Class bronze, let's do 10 for that. And then we'll do class, let's do FCoE next, because there's something special with this class. We'll do bandwidth % 30. For that, because it's gonna, let's just say this is a pretty SAN intense switch in front of a FlexPod or VBlock or something like that. And then we do queuing class default, bandwidth % 10. And I'm sorry, I'm just counting, making sure these match up to 100, and they do. You'll also notice that there is a priority keyword up there, and that allows you to give a certain traffic class the priority queuing. If you want to learn more about that, that's probably something you should study in just general QoS. That applies to iOS and Nexus as well. There's another QoS type that we haven't touched yet, and that's network QoS. Now, this is really the main kind of core of the QoS configuration, because this is really where you do a lot of changes to the traffic. And I'm trying to create a class map of type network QoS. And again, because we need to classify the traffic based off of what we discovered. Hold on, give me a second. I'm trying to figure this out. Okay. So let's do class map type network QoS class platinum. There we go. Okay, cool. And we're going to match on QoS group just like we did with the queuing. If you go back, you'll notice that we're matching on QoS group here, and that's fine. The queuing class map and policy map were for the egress traffic. We can use the class maps that we're matching based on QoS group, because QoS group is a way to kind of interject traffic between types of class maps. So we're matching based on QoS group just like the other types of class maps did, which is cool because network QoS class maps or policy maps do completely different things than type queuing. So we're matching. We're basically creating the exact same class maps that we did before, but they're just the network QoS type. And if you look, the class FCoE is actually currently in use by the existing policy map, so we can't change it. But we're really not changing it because QoS Group 1, like I mentioned before, is the default for FCoE. So it's just giving us a message saying, hey, this is activated. You can't really mess with this. But good thing for us, it's we're using the default values, so it's not really a big deal. So as I mentioned before, we've got an outlink out policy that's going to change the policy for what we've got on the switch going out those packets, which is where we can do bandwidth reservations. System level QoS is the keyword that I gave for that policy. You'll notice that the network QoS type for those class maps. And finally, at the end, we actually have the application. And I haven't touched these yet, so they're still the defaults. The switch comes with some basic policies, and like I said, most of them are just centered around protecting FCoE. So all of these policies are written to make sure FCoE works. Everything else is pretty much just treated as best effort. And they're so default, they're so baked into the switch, we can't even show them. It's just a way of treating FCoE by default. So let's do show class map type network QoS just to see what we just did, because we created these just now. Like before, we do have a lot of default class maps for capturing both default traffic. We also have class maps for capturing all flood traffic and IP multicast traffic. So now, just like before, just like the last two types, let's create a policy map for this type of QoS, network QoS. And let's see, we called the last one, where did it go? Policy map, we already named it that, so let's change it up a little bit and just do net QoS to keep things simple. This is just the name. It can be whatever you want, but I name it like this so I know that this particular policy is of network QoS type, so it makes sense in the config. You can have the same name as long as the policy maps are different types. I just prefer to keep it unique so I don't confuse myself or a future admin. But just like before, we match on classes that we already created, so class type network QoS class platinum. We can actually set cause values, because remember, this policy map is leaving the switch now. So we can set cause value of 5. So traffic that has made its way into this class platinum, and is now leaving the switch will get marked with a cause value of 5. Same with class gold, cause value of 4, and then class FCoE, we can actually set with a cause value as well. But first, I'd like to take a moment and look at this. The pause keyword is important. There's a spelling error right there. The pause keyword is important because what this does is it enables us to run a no drop policy for FCoE traffic, which is great because FCoE it's a requirement for FCoE to have a pause no drop policy. It's also important to change the MTU. So here's where we can get into MTU on a QoS. Most people aren't used to configuring MTU on a QoS policy. They're mostly used to configuring it globally on the switch. But actually, we can configure it per class, and 2158 is the default MTU for that class. You'll also notice that we cannot set the cause value for class FCoE because the cause value of 3 is the default class, or the default cause value. Moving on to class Silver, as I mentioned before, we can set the cause value. Let's set it to 2, and also we now can set MTU based on traffic class. So rather than enable it globally for jumbo frames, let's just say Silver gets jumbo frames treatment. That way we can guarantee that only the traffic that needs jumbo frames will get it. So MTU of 9126, and let's just as a use case, NFS would be a great example of this. vMotion would be another great example. If we can figure out a way to classify traffic, either by cause value or IP access list, whatever, we can get it into the class Silver class, and then give it jumbo frames. But then the cool thing about that is that we're not just enabling jumbo frames globally on the switch, which is nice. So moving on, class Bronze, we'll set a cause value of 1. Class type Network QoS class default, and again, this is the default class. It's a native class to the switch, but we'll still make some changes to the default traffic because we want to do a few things. Multicast optimize is a unique keyword. Actually, what this does is it enables the typically unused multicast queues to increase performance. So for this particular implementation, I'll enable it because I know that there's going to be multicast traffic in the default class that's going to be unmarked. Now we can enable these policies that we've created on a per interface basis because we've created all these policies, but we haven't applied them anywhere. So it's important to look at this. We can do it in input or output on each interface, but I want to show you something first. We've got a policy that shows our uplink out policy. We've also got a few other policies that we created, but I want to take you to the system QoS command, because what this does is the same thing in terms of application as configuring it on an interface, except that the policies applied here are applied globally to the switch. And if you look at the show run, which we were looking at earlier, let me put this in quotes. If you look at that, you'll notice that that's how it's been applied already. So not only are there default policies that protect FCoE, but they've all been applied globally, which means every interface has these policies applied. Your mileage may vary on this. Obviously, don't apply it globally if you don't need it. I just found it to be easier because I want things to be simple and consistent across all my interfaces. So the first thing we want to look at is the type QoS input policy. We won't actually be changing that policy. If you look at the first one we made, we do have a policy map of type queuing. So we will want to apply that policy on the global system QoS configuration. So service policy type queuing, and we'll do input and what did I name that? Oh, you know what? This is yeah, they're out of order. Let's see. Let's do queuing output, and let's use that uplink out policy. You know what? Let's make sure. I'm gonna copy and paste it. I just want to make sure we get no typos. Very important when you're applying this to a live switch that you make sure that everything's consistent and that you don't make any typos. It will bring your system to its knees if you do something wrong. So that's applying the policy of type queuing outbound. So all of those traffic shaping policies that we did are now in effect. We can also do the system level QoS, which initially classifies the traffic. So we'll use system level QoS for that. And you'll notice the policy map here is where we set the QoS group. So that's what gets it initially classified. Those class maps, if you remember, those class maps match based on cause. So that will get the traffic into these QoS groups. And then the first policy that we applied, that uplink out policy, will be the first one to match based on QoS group, and then do stuff with the traffic, which for that policy was bandwidth shaping. Here we have our type QoS class maps where we actually do match based on cause. So back to the current QoS configuration, we have not made any changes to the queuing input policy, but we have applied QoS input for system level QoS. That classifies the traffic, and then we've done queuing output, which does that bandwidth reservation that we saw before. The one that we haven't touched that we need to touch is this network QoS policy. So we do have a policy for network QoS. Let's get into system QoS and make that change now. So service policy, type, network QoS, and this is going to be system-level-net-QoS. You know what? I want to make sure that that I have the name right. So here's the policy map that we created, and we're just going to grab the name here shortly. And service policy type, network QoS, and we're going to grab the name and paste it in. There we go. So now that should be applied. Exit. So another show run, and now we're going to go over the configuration as it stands now. As you can see, we have quite a bit more configuration than we did before. At first, we have our first class maps, which match based on cause. So as the packets enter, or as the frames enter rather, they get matched on those cause values. The policy map of that type will take the classes that were just that were just created, and it will set QoS groups for that traffic. The next class maps of type queuing will match based on that QoS group, so you got to make sure that those link up the way you want them to. And then the policy map of that type will apply bandwidth percentage reservations for each class. The final type is network QoS, which, like type queuing, can still match on QoS group. So type network QoS for all of these class maps. And finally, the policy map that we created can actually take the classes of network QoS type and do other stuff with them. And then finally, the application is the most important part, where we actually make these policy maps do stuff for us. And again, applying them into the system QoS context applies it globally. So here's a cool command that we can run: show queuing interface eth11. As you can see, we ran this at the beginning of the video, and now it's drastically different because now we have many more QoS groups. The scheduling type is weighted round robin. If you want to learn more about that, please watch a pretty standard QoS video series to teach you a little bit more about that particular scheduling type. The operational bandwidth for each of those queues is there, and actually you can see more detail on each one of these queues. So 1500 is the default queue for QoS Group 0. QoS Group 1 is FCoE, that's why there's a MTU of 2158. And as you can see down here for QoS Group 3, that was our silver traffic. If you look back up in this policy map, we've applied an MTU of 9126, and that MTU is shown here in the output. So as we receive packets on that QoS group, or rather the silver class that we've created, the human readable name, we'll be able to see that traffic enter. So let's go over to switch B. We've been doing most of the configuration on switch A. I just want to go over switch B's configuration real quick. We do have an interface here. We pinged it before and we know it's working. The IP address is 10.1.1.2. You know what? I want to run over to A real quick and save my config. So on A, I can show the queuing again. And again, this just shows the interface statistics for each the QoS statistics for each interface. Okay, good. Yeah, I'm just showing the port channel stats because I would rather have one interface down so I know where the traffic is going. This is not an exercise on how to configure port channels, so I'd rather just have my traffic be very I want to know where it is. So we can ping 5K from 5KB. As you can see, we just ran some pings. If we look at the queuing for the interface 1.1 on that first switch, we'll see that those pings weren't really anything special. So they fell into the default class, which is QoS Group 0. We can even see that the number of packets received over the port. So that's pretty cool. If you look at the first classification method, if you will, we've got the class default, which is where the traffic by default will fall into because we haven't done anything really to mark any of the traffic we're sending from the SVI on the first switch. So what we want to do now is figure out how to get the traffic that we are sending into a higher echelon of traffic classification. Let's do silver because what I want to do is I want to show you how the MTU is on a per class basis. If you look at the silver class for our policy map, like I said, we have an MTU of 9126, what we'll do is we'll send some pings from 5KB that are larger than the standard MTU of 1500, and on switches, what will happen is if it's too big and the MTU is smaller than the size of the packet, then it'll get dropped. So we'll know if it's working. We can change the MTU with the packet size command. That was not supposed to happen. Interesting. Yeah. So I pinged myself. So I pinged the address on 5KB. So it was basically a ping to itself, which of course would succeed. Let's do that again. Hold on. Yeah. Yeah, so yeah, it did not receive any of those. All of the queues are still 0. So none of the counters went up. Okay, we are back on 5KB. Let's do the ping correctly this time. Ping 10111, which is the address of 5KA, and this should fail. The reason for that is because we really aren't doing anything to classify this traffic, so the traffic is going to fall in the default class. And if you remember the configuration on 5KA, that traffic has an MTU of 1500. And just like any other switch, when a frame is received that is larger than the MTU, that frame is dropped. So we dropped all of those packets. Let's hop back over to 5K and see if we can find out where that traffic is going. So show policy map type network QoS. You'll see that class silver is what we want to go for because that has the higher MTU. So the question is, how can we get traffic to be classified as class silver? We've set up the framework, but what we really haven't done is placed a mechanism within this configuration other than cause value that classifies traffic. And we're not marking cause value for the traffic that we're sending. So right now it's just getting classified as default. So let's go into that QoS or type QoS class map and see if we can find another way to match this traffic. As we saw before, we can match based on a bunch of different stuff, but one thing that I want you to look at is we can match based on access group, which is really an access list. So let's create an access list that matches the traffic. We'll call it match underscore N5K B. That works. And we'll just permit IP. We'll just do host because we know what the address is, 10.1.1.2, which is the address of 5KB, and we don't care about the destination, so we'll just say any, and that's fine. And so what we're doing here is we're matching based off of that traffic. We're matching the IP address that's being sent from, and that's how we will classify the traffic. So now we refer to that access list by saying match access group name match N5KB. Oh, that's interesting. So apparently you cannot have multiple match criteria if you're using access group. So we will have to no match cause value of 2, which is what the current match statement was up here under silver, match cause 2. So let's kill that, and now we can match based on access group. So that should be good. Interesting note, though, I did not know that you couldn't do both. So I'm switching cables here in a little bit. Okay, cool. So let's do the same thing on 5KB. So you saw that the timeouts occurred there. We aren't doing anything to classify the traffic here, so let's do it here as well. IP access list, N5K. So let's just do N5KA. Permit 10.1.1, or I'm sorry, permit host 10.1.1.1. I swear I've done this before. Permit IP. Ugh. What am I doing? There we go. Okay, cool. Lost my head for a second there. Okay. Same as before, we're just doing it from the other direction. So no match cause 2. And now we're matching based on access list, so we'll do match access group. And we will use the name that we just created, N5KA. Name N5KA. Syntax is important. Exit. Now let's do another ping. Okay, timing out. Interesting. Let's start a large packet stream, and we'll go take a peek over at the other switch to see if we can find out what queue that traffic is going in. So while that ping is going, we should be able to go to the queuing of that interface that we saw before and watch the counters go up. So QoS Group 3 is the idea. It looks like it's going up. I'm going to keep pressing up and enter here just to keep watching for QoS Group 3, because remember, QoS Group 3 is what we expect it to be in, because that's basically the QoS Group representation of class silver, which has that higher MTU, as we can see. I want to take a moment I paused the video for a while. I troubleshot this for a while, but I figured out a few things. What I want to point out is I've made a few changes. The first thing you should notice that I changed the access list to make sure that the name is consistent, because I noticed that they're different. I also matched based on the entire subnet and not the specific address, because I wanted to match in both directions. So if you look, we have the correct MTU of 9216. It was 9126 before, another snafu on my part. Wouldn't have mattered, we were pinging with size of 8,000, but just to cure my own sanity, I made it right. If you look down here under these MTUs, you'll notice that the default class is also 9216. Part of my troubleshooting, there's a few commands that I ran to just see if it was an MTU related issue. The issue is related to MTU, but just not this particular type of MTU. I'll get there in a second, but what I'd like to do now is undo those changes that I made so we can go back to where the configuration was before I pause the video and troubleshoot this issue. So no MTU 9216 for default class. So now default traffic will no longer get jumbo frame treatment, just like it was before. So the regular MTU of 1500 will apply. The other thing that I would like to point out, and again we're changing the MTU back to 1500 by doing no MTU 9216. I'm just making the change on both switches. Exit, exit, exit. And again, there's another command that I ran. You can do system jumbo MTU 9216. Again, I don't want to classify anything globally. I'd like to do it per class. So I'm going to do a no system jumbo MTU 9216, returning the system jumbo MTU state to the regular MTU, which is 1500. And now I'm going to do the same on 5KB. So now we should be completely back to the beginning. Let me show you now the layer 3 interface that we've created that we've been pinging from. And that MTU is 9216 because I changed it just before I resumed the recording. If you go to interface VLAN 20 right now, or rather, I'm going to create a new SVI for VLAN 20 and just give it a dummy IP address. You can see that the default MTU for new layer 3 interfaces is 1500 bytes. Now this is a layer 3 MTU. This is different from the MTU applied to the physical interfaces that are layer 2. So we can change the MTU of these layer 3 interfaces. So let's get rid of VLAN 20. It was just a test I was trying to show. The default MTU. Let's go to int VLAN 10, and now let's ping the other side. We can see that with a regular packet size it works, and if we change it to 2000, it also works. So the problem was that the layer 3 MTU was not correct. This is probably something you won't have to run into if you do a real test. I ran into this issue because I was actually testing with layer 3 interfaces directly on the switch. Normally you would have PCs plugged into each of these switches, and you would set the PC's NIC, the MTU of that NIC, to be jumbo frames. So basically it was a weakness in my own test. So that's it for this video. I hope you enjoyed it. Please, let me know what you thought. This is a pretty informal video. I don't know if you could tell during the video, but I actually recorded my voice well after the recording of the screen. And that was just an unfortunate way of doing it because of my environment. It was very noisy in the location that I was at to record this screencast. So unfortunately it was what I had to do. But nevertheless, I hope you enjoyed it and I hope you learned something from it. I certainly did. I have not done a ton with QoS in my experience, so this is a learning experience for me. And I would really appreciate your constructive feedback in the comments. So please drop me a line, let me know what you thought. And I plan on doing more Kick Labs here in the future. I actually do like doing these screencasts as long as it's of interest to you guys. So feel free to drop me a line and let me know what you thought. And thanks for listening.